See, we've been talking about this all year, so why do I need to take a day and talk about it more? Two reasons. Identifying problems where I can use Pythag. And then the second half today is Pythag can also be used to do something else than find a side. Okay, it's also got a little bit more power. The basics, you know about it already. Throw anything at me here. Basics you know about Pythag. What do you know about it? Anything. Throw it at me. 7. First of all, it's got to be a right triangle. Right? I can't use Pythag any other way unless the triangle is a right triangle. What is Pythagorean theorem? What is that bad boy? So I can write it down. 20?
A squared plus b squared equals c squared.
Yeah. And I just want to make sure we're solid on what A and B are. You plug in the legs. Where are the legs located on a right triangle?
They form the right angle.
They form the right angle. Thank you. A and B. And then across from the right angle is what we call the hypotenuse, and that's C in the Pythagorean theorem. Okay? We're all okay there. All right. So let's couple problems where I can use Pythagorean theorem, even though, look at this first problem. I have a parallelogram. Where the heck does Pythag come in then? I'm looking for the perimeter of this parallelogram. First thing I need, what do I mean by perimeter there? So I know where to go. 10, what do I mean by perimeter? All right, good call. Thanks. How about 28, perimeter?
Distance of both sides.
Yep, and I already know one of the sides. How long is one of the sides? 11. And because you know your properties of a parallelogram, you're darn right you do. What's another side length then? Opposite sides congruent. So I just need your help. What about the other two sides? All right, how can I find the other two side lengths? Well, has nothing to do with the parallelogram. Everyone see the right triangle I built by dropping down this altitude? I can use Pythagorean theorem to find the other side. So even though this problem is about a quadrilateral, I'm still going to involve Pythag. Somebody set that Pythagorean theorem up for me. 5. Good. I gave you the two legs, A and B, and we are looking for the hypotenuse, a.k.a. the side of the parallelogram. Good start today, 8th period. Good start. 36 and 4. C squared equals 40, and I'm not even going to assume this. How do I get the C by itself? How do I get C by itself? 1. Not here? Oh, never mind. Sorry. 2.
You square root both sides.
Take the square root of both sides. Good. Square root of both sides. And everyone sees the directions clearly. Leave it in simplest radical form. That shouldn't be a shock to us. So somebody break down 40 all the way and let me know what that side length is. When you have it, let me know. It's 22. Breaking down 40.
10 and 4.
What do you got?
10 and 4.
Okay, keep going.
And then it would be 2 outside the radical and 10 under the radical.
Thank you. 2 radical 10, which means the other side's 2 radical 10. All right, we need to have a little discussion now. How do I add those? Because I don't know what the heck you did last year in Algebra 1 as far as radicals go. All right, so we need a little, because hey, I'm forewarning. This is not the only problem all year I'm going to ask you to add radicals. Probably will come up tonight on the homework and, maybe on the quiz. I don't know. I made it up. Might come up on the quiz next Tuesday. What can I add and what can I add? You cannot add all 4 of them. You can't combine all 4. When can you add a radical to another one? When what is underneath is the same. Everyone see I got a 10 and a 10? You can combine those then. If I had this, 2 radical 10 plus 2 radical 7, you are not touching them. That is done. I can only add them when the numbers underneath are the same. So what does that become when I do add them? What's the numbers out in front? 2 plus 2, 4. Do I add the numbers underneath the radical? No. Radical 10. Only combine if the numbers underneath are the same. And then there's still something else I can combine. The 11s, right? Plus 22. And I get it. It's probably freaking you some of you out. I can't leave it like that. It's just got to be one thing, not 2. You're done. Why can I not add these two? This 22 does not have a radical 10. So this is your perimeter of the parallelogram. If you want to put feet with it, fine. I gave up a couple years ago trying to have kids put units because on the Regents you don't get credit. You don't get credit off if you don't put units. But so I'm not going to fight it. We okay on adding radicals? Not the last time you'll see it. We sure. All right, moving on. To get from point A to point B. Okay, can we just quick discussion here? I wasn't here when he made his first appearance on your test or quiz, but have anybody noticed that our boy here, Big Al, does make frequent appearances on problems and tests and quizzes? Yes, he is a celebrity in honors geometry, a celebrity. He is a person, existing person. He'll come up in more and more problems that we do in tests and quizzes. Who is Big Al? I will reveal that last day of class in June. So you can have all the guesses you want. He's amazing. You'll see he's trying to walk through a pond here. He builds farms. You'll see all different types of things Big Al does. All right, but he is a celebrity. So I just wanted to introduce officially Big Al to everybody. But you got another 4.5 months before I reveal who Big Al is. All righty? So, moving on for Big Al. He's going to try to avoid walking through a pond. So to do that, he goes 34 meters south, 41 meters east. But you know what? How many meters could he have saved if he could just walk through the water? All right, how many meters could he have saved if, you know what? I'm just plowing right through this bad boy because I'm Big Al. How many meters has he walked already? How many meters has he walked already by avoiding the 75, right? He went 34 meters south plus another 41 meters east. He's going 75 meters so far. Well, what about if he went through the pond? How many meters would he have walked if he went through the pond? How do I try to figure that out? Here comes the south and the east. Do I need to put the compass up? Never eat soggy wheat. I think that was 3rd grade, and I think my daughter came home with that the other day. I was like, oh, good, great. You can tell directions. Do some math. Sit down. 34 meters south. East. East. No. I'm not a pointer here. Where am I going? East. To the right. Good. We go to the right. Just waiting for somebody to say right. Everyone's like, that way. No, just tell me right. 34 meters south, 41 meters east, and then the pond. If you could walk through the pond, there's your pond. So let's figure out if you walk through the pond, how many meters that would be. Can we set up Pythag here for me? 3.
34 squared plus 41 squared equals c squared.
Forewarning, I'm about to get fired up here in a second because this is the first time that this has happened in this class this year. And it won't be the last. So I'm going to make a huge spectacle up here in a second. What do I get there? 2,837? When I add those together. And then you take the square root we just talked about. To get c by itself, you take the square root. Yep. And I'm not going to have you break that down. Don't worry. But everyone's going to their calculator right now and doing square root of 2,837. Okay. First time this year this is happening. Is that number right up there, 53 and change, my final answer to the problem? Is it going to be my final answer? I'm going to circle it and move on to the next one. No. And I'm asking you that because we don't round this number on our own. If it's not your final answer, you don't round it on your own. You write it all out. The only thing we round is our final answer. And you guys are honors kids, so I'm going to tell you why I get so fired up about this. There are problems that you're going to end up doing where if you round in the middle, it's going to throw off your final answer and it'll be incorrect. Oh, I got to write all this out? Yeah, you do. I'll go down to the health office and get an ice pack for your wrist if you need it. Okay, write it all out. Bless you. All right, so if you're in the middle of a problem, you write the whole calculator display out. C equals, and I'm going to do it myself just to prove that nothing hurts. Your hand can deal with it. 53.26349594. If it's not the end of the problem, you don't round any decimals. All right, now, so that's across the pond. How are we going to figure out how much we saved then? If Big Al could walk across the water, how do we figure out how much he could have saved by doing so? Talk to me. 19? 75 minus, and you can do this. I'm okay with this if you want to pull that off so you don't have to write it again. Minus that. And every year I am amazed by what you don't know about your calculator from Algebra 1, what you were never told. Do you realize you do not have to type that number in again? Some of you, most of you can just highlight it and press enter and I'll copy it for you. If you can't do that, everyone there see there's an ANS answer above your negative sign. You can do second negative and it'll plop your previous answer back in. So hopefully some of you guys aren't typing it in. I know you guys were deprived last year. Whoever you had, deprived. And there you go. Now, is this my final answer? Yes. Now you can round to what the direction says with the nearest tenth. And this still fires me up because kids get silly points off on the Regents in June because they don't know how to round yet. Nearest tenth, what are we looking at? Round that to the nearest tenth. We're looking at it's 27. 21.7. There you go. And again, I don't care about the units if you want to put, where we got feet here? Meters, sorry. You want to put meters. Alrighty. So, am I concerned about Pythag here? No, but just know, don't round anything in the middle. Wait to the end. Oh, what's that you say? You want to do a high-level algebra problem? Sure, you got it, guys. I know you were waiting for one. Doesn't look like much, right? Doesn't look like much. Pretty basic. I got a right triangle. I know 3 sides. Who's going to set up Pythag for me? 21.
8 squared.
Yeah.
Plus x minus 4 squared.
Okay, let me stop you there. You're correct, Dan. How do I write that? What you just told me? Thank you. We're not doing x minus 4 without it. Parentheses squared. Go ahead, Dan, equals?
X squared.
X squared. Good. Who's going to make their algebra teacher proud? Probably not many of you. 64. That's no issue. What are you doing with that? Because if anybody's going to say, oh, I know, x squared minus 16, your algebra teachers are embarrassed. Highly embarrassed. No, you do not just apply the square to the x and the 4 and go, oh, no. Anybody? How do I deal with that? Dylan? Okay. You're saying FOIL, double distribute. Where does that come from? How'd you know this was 64? You did 8 times itself. If I say 3 squared, everyone's spitting out 9. Why? 3 times 3. So if anytime you square something, you multiply it by itself twice. So yes. And then that's where the FOIL double distribute comes from. So I will give you guys a minute to go ahead and for the 64 can be added on at the end. Don't worry about the 64. I just want you to take x minus 4 times x minus 4. X times x, x times negative 4. Whew. High level algebra here. And we haven't even gotten to the good stuff yet. Wait till we clean everything up. Then people are just going to start sweating profusely. 64. You should get negative 4x in the middle. Positive 16 at the end. Before I combine any like terms, that's what I end up getting. Negative 4x plus 16. How about a little cleanup? Let's clean that up on the left side. Let's put the x squared where it belongs out in front. What's the deal with the x's? How many you have there? 8. How many x's do I have there? Negative 8x. And how about my 64 and 16? I can combine, and I'm left with 18. 80. Whew, here's where it gets good. What do I do next? What do you think? What do I do next? A lot of panic right now. There's a couple, by the way, there's multiple answers what you could do next here. One of them is not take the square root of both sides. Sorry, I don't know how you're going to do that on the left side. What's up, Dylan?
Subtract one of the x squareds over.
Yeah, but look, what have we been saying all year? You see an x squared get one side equal to? Yeah, okay, go ahead. Oh no. Oh, we're panicking, aren't we? We're panicking. Why? Why are we panicking? What's going to happen to the x squareds? What's going to happen to them? See ya! Panicking? Some of you should be celebrating. Because that means if the x squareds are gone, you don't have to factor. And I've seen some of you try to factor. You should be celebrating right now. All right? Celebrating that you don't have to factor. You just get negative 8x plus 80. Am I just going to leave it that hanging there? No. What's it equal to? All right, go to work. Get x by itself. Don't overthink this. There's no factoring. Move the 80 over, and then get rid of the negative 8. So this wasn't as bad as it seemed. So my x value here ended up being, when you're ready, 24? 10, positive 10. Yep, good work. That's the one that doesn't come up much, is it? Doesn't call out on you very much, right? 24 doesn't come up much. I think I probably just jinxed it. Questions on Pythag before I show you another use other than finding a side of a right triangle? We're all good? All right, quick question before I get into show you the other use of Pythag. What's that? I know, I wrote it up. I know it says acute. You don't need to repeat it. What is an acute triangle? All angles less than? I don't want to do that. That's going to be isosceles, but still acute. How about 20, 50? What's left? That's not even acute. I'm going awesome here. I'm thinking 90. 80, 50. It's still 50. All right, how about I go 60? That's 140. So there's an acute triangle, right? What about this? At least one angle is bigger than 90, right? So what you're telling me here is I can only say if a triangle's acute or obtuse if I know the angle measures. That's basically what I need to know the angles to say acute or obtuse. Not today. Not today. Here's what I'm about to show you today. 20, 16, 15. Just by knowing the sides, you'll be able to tell me if it's obtuse or acute. You don't need to know anything about the angles now. All right, how? Using Pythagorean theorem. All right, using Pythagorean theorem. How does that work? Here you go. What you're going to do, I'm going to give you 3 side lengths. Let me just do a quick one right here for you. Give me 3 side lengths. 5.
6. 4. 7.
Okay, 5, 6, 7. How can I tell if that's acute or obtuse? I'm going to take the 2 smaller sides, plug it into Pythag, 5 squared plus 6 squared, and I'm going to compare it to the biggest side squared. So I get 25 and 36. I get 49. I add those 2 together. What do I get there? 61. If, in this case, if the a squared and b squared is bigger, I got an acute triangle. If it's reverse, that the c squared is bigger, I have obtuse. Well, what if they're equal? We've been doing that all year. When have we set a squared plus b squared equal to c squared? Only if I have a right triangle. That's why. So if they come out to be equal, it's right. So that's what I'm going to do with the three sides right now. I got two separate examples for you. So first one, if I have a triangle of 9, 12, and 15 as their side lengths, 9, 12, and 15, just by knowing their sides, what type of triangle is it? I don't need to know anything about their angles. So we're going to go 9 squared plus 12 squared. How does that compare? Notice I'm not putting an equal there because I don't know yet. How does that compare to 15 squared? $81, 144, 225. 81 plus 2 plus 144. What do we find out that is? 200 and? Okay, so they ended up being equal. So 9, 12, and 15 are sides of a right triangle. Those would be three sides that form a right triangle. We okay? And then what about 10, 11, 13? 10, 11, 13. What type of triangle do I have? Again, hey, I made this way too convenient and easy for you. Make sure you pick the two smaller sides for A and B. All right, I just listed, if I go 13, 10, and 11, I'm not asking you to put 13 and 10 in for A and B. It's whatever the two smaller sides are. Got to change that up for next year. 10 squared, the two smaller sides go in, compare it to the largest side squared. Oh boy, 10 times 10, got to do your doubles here, just like back in the day. Plus 11 and 11, 121, 13, 13, 169. What do we got here? Not equal? 221 compared to 169. All right, what happens if my A squared plus B squared is bigger? This is an acute triangle. Yep. If you're not already, prepare to be so miserable. Go ahead, graph. And if you're miserable, that means that's bringing me some joy. 1, 2, 3, 4, 5, 6, 7 groups. I already see the cringing. I love it. Okay, what type of triangle is it? And it's just not going to be, oh, it's acute. Well, why is it acute? Because it looks like it. That's always a good explanation in here. Nope. And you're not going to be able to find the angle measurements either. There's no way in a graph you can find the angles. So we're going to have to find the side lengths and plug them into Pythag. How are we going to find the side lengths? Yes! Let's go! Distance. I love it. Yes. Because you hate it. Distance. I love it. X squared minus x1. But sometime today, by the time I woke up to now, some ice has melted off my heart. So I'm going to make this easy on you guys here. Claire, your group's going to find XY. These two groups, in fact, are going to find XY only. You don't need to find the others. Maddie, what do you want to find? YZ. This whole crew right here, YZ. And this other two groups in the back, what are we left with? XZ. That is your only responsibility, please. You don't need to find all three. Also, no need to put it in simplest radical form. Who cares? All right, just leave it underneath the radical. So find your side length, and we'll see how it fits in the Pythag.
Can I grab my calculator?
Yeah, go ahead. If it was not your responsibility, please make sure you jot it down. All right, there's 7 of you. Can't screw it up. XY? Radical 29. Good job. Square root of 29 was the distance of XY. YZ, even more people. 10 people.
Radical 20.
Radical 20. Again, there's no need to break it down. Okay? No need to break it down because we're just going to plop it in the Pythag. XZ, oh boy. This crew of 8.
13.
Radical what?
13.
13, yes. All right, how does it fit in Pythag then? First thing, I need the 2 smallest sides, which would be what? Okay, radical 13 squared plus the next side. Radical 20, I take the 2 smaller sides. See how that compares to radical 29 squared. We're going to our calculator for this, huh? What happens when you square a radical? Doesn't it undo itself? Right? That's why when I say, hey, how do you get rid of this squared? You take the square root, they undo each other. So this is 13 and 20. I get 29 over here. Ooh, looks like the a squared b squared side came out to be 33. C squared side's 29. So finally here, a squared plus b squared is bigger. So this would be what type of triangle? 5 based on its sides? Acute. Good work. Acute. One more, and this is all going to be done with discussion with your group. I am not going to say a word. Go right ahead, you and your group.
Big L.
This is a great little review problem right here. It involves Pythag, congruent, and similar triangles. Discuss in your group. And that's his brother, if you're wondering. He's not real. All right, I don't have a real little Mike. All right, what do we say here? Do we find the missing side of this first triangle? It came out to be 12, 13. And the missing side of this triangle ended up being 13, 12. Anybody see that symmetry there? Okay, never mind. So are they both correct? Well, let's talk about the congruent part. I think that's pretty obvious. They are congruent, but you still need to tell me why. So they are congruent because. All right, give me a method. Right, we got 5 methods out there we talked about all year. You could write side, side, side. Anybody put another method? We could do side, angle, side. Oh, and there's one more. HL. We got a right triangle on our hands. Yep. The similar part may have been a little bit more difficult for a few of you there. They are similar though. They are. Why though? Okay, I heard a lot of because congruent triangles are similar. Did anybody use one of the 3 methods of proving triangles similar? You could use side, side, side. Are all 3 sides in the same ratio? Yeah, 1 to 1. Or you could have used side, angle, side. So they are similar because of side, 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 angle, side, or all congruent triangles are similar. Any one of those reasons would be perfect. All right. Last thing before I let you go. Actually, 2 things. One is there are no rounding directions in your book. I'm putting them on the bottom of the page right now, though. Everyone see those? Okay, they're not in your book, but that's what I want you to round to. Second thing, I think one of the problems you're going to end up doing Pythagorean theorem with is like 1 1/4 is the side. Do you know you can plug that in your calculator? You know where you go to get your fraction template? Alpha y equals. Instead of using this one, you chose number 2, and you can have 1 and 1/4 there. Okay, so no reason why we need to be scared off by those. Let's get rolling.
I get to pick yours.